We're now going to take a look at the division algorithm for integers and try to make some connections between that and congruence. But before we do that, I have some activities available for you to look at. It's in the file called division algorithm with this video. I encourage you to look at that before this video. It'll help you understand a little bit better what's going on here. I should note that these activities are only for to help you with your understanding. They will not be included on the quiz. So we're going to be looking at the division algorithm and its connection to something called the mod operator. So we're first going to review division and remainders. We're going to make a connection between division and remainders with congruence, and then we're going to define the mod operator. And finally, look at some examples. So let's see what happens when we divide 6 into 53 and find a remainder. So 6 goes into 53 almost 9 times, right? So it goes in there 8 times. If we do 6 times 8, we get 48. And if we want to figure out what the remainder is for that, we just take that 48 and subtract it from 53 to get 5. In general, what's going to happen is you're going to divide some natural n into some integer b. So you're doing b divided by n. You try to find the biggest multiple of n that is not bigger than b. So it's nk for some integer k. Then we're going to take that nk, subtract it from b to get that remainder. So we get b minus nk equal to r. This is exactly the same process we did on the previous slide when we divided 53 by 6. Notice that if we add nk to both sides of that equation, we get b equals r plus nk. And that should look a little bit familiar because it looks exactly like congruence. It's exactly the equation we got for b being congruent to r mod n. So if we have n as a natural number and a as an integer, another way of thinking about what the remainder is from dividing n into a is being the smallest non-negative integer r such that a is congruent to r mod n. So finding remainders and solving congruences are two different ways of understanding the same thing. So we have a special name for this remainder. This remainder is called a mod n, the mod coming from the congruence part of that definition. Of course, in Python, it looks a little different. It's a percentage sign n. So if we want to find 50 mod 7, what we do is we figure out the biggest multiple of 7 that goes into 50. That's 7 times 7 equals 49. We subtract that from 50 to get 1, which means that 50 mod 7 is equal to 1. If we do 63 mod 10, 10 goes in there 6 times without going over. 10 times 6 being 60 gives us 63 minus 60 equals 3. And that means that 63 mod 10 is equal to 3. So in general, a mod n is going to be some integer between 0 and n minus 1, which isn't too surprising. Those are the types of numbers that we got when we did division of integers. So it gets a little bit more tricky when we want to find huge numbers mod other numbers. So say 100,000 mod 7. And one of the things that we're going to explore in the next set of activities and the next video is what kind of techniques can we use so that we don't have to just do a massively nasty long division on that one. So we're going to find some more powerful tools in the next set of activities. But for now, try to finish the activities for division algorithm to help you understand what's going on with these concepts. And then also work on the problems in Introduction to the Mod Operator. Those problems are going to be on the quiz, so make sure that you're familiar with those.